How's it going, guys? Angus here from Makers Muse. In today's video, we're going to get stuck straight into some Fusion 360 modeling. Specifically, what I have here is a Blackmagic HDMI External Monitor. It's really nice, and it's sadly not mine, but what I'm designing for it is a glare protector. So what I have here is one that's designed for a 5-inch screen, and obviously it's a little bit too big, so we're going to be designing one for this one specifically to fit it perfectly, and we'll print it out in black PLA. Let's get started. Welcome back, guys. So as I said, this is a HDMI external monitor for some sort of purpose. I don't know what they're using it for, but it's a really nice one. If I had it, I would be using it for my videoing. But basically I need a glare screen or glare cover for it. So tools of the trade, you're going to need some measuring tools. So what I have here is a ruler and a pair of digital calipers. So ideally you want a really nice pair of vernier or digital calipers. These are some pretty cheap ones, like 10 bucks or something. I got them quite a while ago. But they'll do for our purposes. But before we even jump into Fusion 360, we want to draw what we're going to model. And this is really important. I always recommend that you draw and plan what you want to model before you model it. And that's because you don't want your creativity to be limited by your knowledge of a certain bit of software. And that will happen if you start modeling straight away. So let's grab a pen, let's grab our calipers, and let's figure out what we're actually going to make. Alrighty, so it's a very quick sketch, but this is what I've come up with. Basically, I've tried to copy the other shade, other sort of glare shield, I guess, and I've just made it fit this monitor. So I've got this really basic shape here with the dimensions. So I've got 138 by 90 millimeters on the outside, then a 4mm wall, and then I've got it sticking out by 50. Maybe too long or too short. That's how much this one sticks out. So I'll try that. The good thing about Fusion 360 is it's parametric, so you can go back and change things and the whole part will update, which is cool. Let's get started. Let's jump into Fusion 360. Alrighty, so we're in Fusion 360 now, and this is a pretty simple shape to design. So I'm thinking what I'll do is I'll do the outline for the hood and then do an extrude. Then I will do a cut to make it into the right sort of shape. Then I will do the two little tabs to make it attached to the thing. So it should only really be 3 operations, 3 sketches. Let's have a look. So first we want to create a sketch. So let's go to sketch, and I'm going to create it on the front plane. So front, select, zoom in, and let's go to start making our thing. So I guess the main shape is a rectangle, really. So let's start with a rectangle, but I'm going to start with a different kind of rectangle. I'm going to start with a center point. Center. So I always like doing things perfectly on the origin. So let's go from the center out, and let's enter 138, and then we need to define the height as well. So let's see if we can do that. Sketch dimension, and let's define the height as 90. All right. And we want to offset it by 4mm to create our little inner wall. But before I do that, I have to guess what radius this is. I don't have a radius gauge, and that's the only realistic way you can accurately measure radiuses, or radii. But it looks like a 2.5mm. So I'm going to go with that, and let's see how that goes. So to do a radius on your sketch, we want to go to sketch, and then go down to fillet. So fillet, radius. And we're going to select these two, and then these two, and these two, and make them all 2.5. There we go. So they're all going to basically follow each other. So if I update this, I can parametrically change my design. So that's pretty good, pretty simple. So we've got design 2.5 fillets, and we've got shape that's now just offset by 4 mil. So this might make the fillet break, maybe, but we'll see how we go. So we're going to go to sketch, and then we want to offset. Select what you want to offset, and then we want to make it offset by 4. But we want to offset it in the other direction. There we go. -4. Cool. So like I said, it did break that fillet because it's, imagine the fillet's here, it can't actually be concentric with it properly. So we can just add another small fillet just to make it look good, I guess. So let's go to sketch fillet, and we'll click around. I quite like that Fusion 360 is not throwing a fit here. Oh, now I'm throwing a fit. I'm not used to the hotkeys, I will say that. So let's go to front again. So you have to hold down Control and then middle scroll wheel click to pan. That's what I was trying to do. Okay, so let's go to sketch again. Sketch fillet, and then let's select these points like that. And I just want a really small fillet just to make it look good. So let's go with 0.5. It might be a bit too small. 1. Yeah, 1 looks good. Okay, so it's not going to be concentric, but it will look good. And that's all we really need to do for that step, basically. So let's just now stop the sketch. And if you see on the left-hand side, we've got our sort of parts and our sketches. So I don't know why it's showing 2 sketches. Delete. That's the other sketch I started and didn't do anything with. Right, so we've got our sketch, and we just want to add some thickness to it. So that's called an extrude. So what an extrude does is it takes a sketch, which is like a profile, and then just sucks it out and gives it thickness. So let's go to create and extrude. Awesome. So extrude, we want to select the profile we're extruding, which is of course the thin profile that we drew. And because we accurately measured down what we want to do, we want to extrude it by 50 millimeters. So 50. How easy is that? So here's our sunshade so far. You can already see it's starting to make that shape. We just now need to start cutting away to further refine it. So let's select this face here, and let's make a sketch on it. Create sketch. And what we're going to do now is cut. So instead of doing an extrude, we're going to do what's called an extrude cut, where it will take away material instead of adding it. Right, so I've got my shape, and I'm just going to start drawing out what I want to cut away. So go to sketch, and this time I'm going to select sketch line. So I'm going to go from here, go down 45. I will refine this later with dimensions, and then down. And because we're doing a extrude cut, we can actually overshoot a little bit like this. There's no harm at all in doing like a nice chunky block. This is what's going to cut away. So happy with that, cancel. And then we can go to sketch and sketch dimension. Right, so what I've got here is the top part goes down 50 millimeters. So I'm going to select the edge of my shape and here and enter 50. Right, so as you can see already, because this shape is quite a lot larger, this might be a bit too deep. So maybe I want to make it 40. Maybe that. And again, we can go back and change any of these dimensions. It's extremely easy to do, and that's why parametric modeling is so powerful. So happy with that. And then it's 20 from the bottom. That's what I've got there. So let's go from here to there. 20. Now I wrote 45 degrees here, but it doesn't necessarily have to be, but we'll see how that looks. So 45. Yeah, we'll see how that goes. That doesn't look too bad. I won't add any sketch fillets in. I think if I'll fillet it later. If you ever wondered if your sketch is fully constrained or not, just grab a point and move it around and see what happens, see what moves. So if I'd move this, can't move it, right? But this one, you can. It's not constrained. So if this was important, you'd want to constrain it to make sure that it's locked in space and also exactly where you want it, instead of just drawing it and hoping it stays in place. So because that's just irrelevant, it's just going to cut away. I don't care about that, but I do care about these ones, which are all constrained. Good, so let's stop the sketch, and let's go into create, extrude. But this time, we're cutting away. So let's select our profile, So select the sketch. Notice it automatically sort of works out where you might want to cut away. So here I had to select all of it because it suggested, did I just want to cut this away? Which is actually all I do want to cut, but it's got that radius there. So select both. And we want to operation, cut. So we're not joining, we're not adding a new body, we're cutting away. And the distance, well, realistically, it's through everything. So that's just, cut all the way through. I'm used to Solidworks where you have an option to just cut like through all, but there doesn't seem to be that kind of option here. Oh, there is. There you go. Here I am like saying, oh, it can't do it, and it can. So extents all means it's going to go straight through your object, which is exactly what I want in this circumstance. Done. Okay. So here we have our shade. It's already starting to look like what we want. We're almost there. So all we need to do now is find out how to connect it. And I suppose the best way to connect it is using these two threaded contact points. So the easiest way to do that would be to use two tabs, which I've drawn on here. So let's start drawing those. So I'm going to select this top face here and create sketch. And again, I'm going to use a center point rectangle just because I like them. So sketch, rectangle, center point, rectangle. Drag one out like that. And also we're going to need a circle as well. So sketch, circle. Again, I like the center point circles. There we go. Right. Cancel, and let's start dimensioning this up. So sketch, sketch dimension. So for this circle, we need to give enough clearance to allow that screw to go through. So if this is a 1/4 inch, it would be 6 point something. So I'm going to make it 7, just to add a bit of clearance. Knowing 3D printing is not 100% accurate, especially FDM, that will mean we've got a nice amount of clearance there. So go with 7 there. And I did measure the distance from the main body, and it's 10. So let's go with that. So here to here, 10. Sweet. And then we just need to allow enough meat around it, I guess. So yeah, let's go here to here, maybe 10. That'll be plenty. And how wide our tab is, we can go from the center again. I guess we could do 10 again. Oh, that moved it. So this is a good example of constraining things. So here, because I entered a 10 there, it moved my circle off center, which is not what I want. So this would be a good example just to demonstrate how constraints work. And in future videos, I'll go into much more detail about how constraints work and how powerful they are. But in this case, I'll just show you how to do a coincident constraint and a center point constraint, which can be very powerful and simple and a great way to stop this kind of thing happening, especially with symmetrical designs. It's quite powerful. So I've got a line here, and I'll draw a line right through. That's fine, like that, all right? So we're going to turn this line into what's called a construction line, which means it's not used to create geometry, it's just used to help construct geometry, like a scaffold. So to do that, right-click the line, and then we're going to turn it into construction, or normal, depending on how you're using it. So this line is now not going to affect our geometry, it's just going to help us line things up. So we can select the line, hold down Shift and select the circle, and then when you right click, it gives us some option for different constraints. So here we have a few different types: midpoint, coincident, or fix. Never do fix. Fix is evil, it's really bad practice. I'm never going to talk about fixing and how to use it in my videos because it's just bad practice. Always use proper constraints. Okay, coincident, that's what we want. Coincident, perfect. Alright, so we've got a coincident constraint between our construction line and our circle. Now I'm going to make a midpoint constraint between our construction line and our rectangular tab. That way they'll always be perfectly in the center, and no matter what we change, that won't break. So we're going to select the end of our construction line, that point, hold down Shift and select this line. Right click, and we want midpoint. Alright, that's pretty nice. Then there's only one last thing we need to change. We haven't told the construction line that it needs to be centered. So if I move it, everything stays perfectly with each other, but it's not going to stay perfectly centered in the shape. So I'm going to select my construction line, point here, and this one, right click, and midpoint. And there we go. We have a perfectly centered shape. So now if I want to thicken up my tab, perhaps it's too weak, I can change this to 15, and this to 15, for example, and everything will stay centered, which is perfect. So let's stop the sketch and let's give it some thickness. So let's go to create extrude, and we're going to select our profile. And I think the main body is 4, so maybe 4 is a good thickness. When you do the operation, as we saw, you can create a new body, you can cut, but in this case it automatically selected for me, which is very clever of Fusion, to join, which is what I want. So we want to join our shape. Awesome. Alrighty, so we've got our tab, and now we need one on the other side. So that would give it a bit more stability and a bit more strength. And we could remodel it. We could remodel another tab, copy the dimensions, do that sort of thing. But I'm lazy. I like to model smart, so let's just use the mirror tool, which is pretty handy and an easy way to copy what we've already done and just paste it somewhere else, basically. So let's go to create and mirror. So there's a few different types of mirrors. You can mirror objects, faces, and features, and what's the pattern components. So yeah, faces, bodies, yeah, features, which is great. So we want to pattern a feature. We want to pattern the extrude we just did. So select. Make sure you have features selected, then down the bottom left we'll select that extrude, and then mirror plane, because we modeled our main shape with the center point right in the middle, we can mirror from the top plane there. And okay, alrighty, so we've mirrored our tab, and you can obviously see there's a bit of a problem there where the tab now on the bottom part is sticking out beyond. So there's 2 different things, probably more than 2 different things we could do here. But what I want to show you now is the power I've mentioned already, but I want to show you the power of parametric design. So I'm going to go back to the original sketch of this tab. Go back here, right click, edit sketch. And here where I had the tab collinear with this part of the design, I'm going to get rid of that, delete. And instead, now I can move it, I'm going to make it collinear with this part of the design. So a little bit tricky to line up, but we should be able to do it. Bottom view. Select, right click, collinear, there we go. So all about lining it up. So now, if we rebuild, stop sketch, there we go. So it's shorter on the top, which is fine, it's going to be strong enough. And now it's perfectly sized on the bottom. The other approach we could have done is we could have modeled these before the cutaway, and then the cutaway could have cut it off completely, which would have worked fine as well. But for this, I mean, it's going to be it's a shade for sun glare, so it doesn't need to be that strong. Right, and the last thing we're going to do to this is purely cosmetic. We're going to add some fillets to make it look rounder and a little bit sexier, I suppose. So we're going to modify and fillet, and we're going to add some nice, sexy fillets. So let's select our edges here and here. Well, they are sexy.
What a weird statement.
I'm an industrial designer. Fillets make things sexier. So here we go. And let's go with 4. Sweet. So the fillets there look pretty good. Now we just want to add some here, I guess, to make it also look nice. So add one there and there. Nope, not there. There and there. And we'll make these quite large, maybe 12. Yeah, possibly even larger. 20? 20 looks pretty good. Let's go with 20. Cool. So that's our design. Pretty happy with it. So now I'm just going to save it as an STL for 3D printing. So the way you save STLs out of Fusion 360 is you go to File and then 3D Print. You select what you want. So let's select the shape. And refinement, medium will be fine. And I don't want to send it anywhere. I just want to output it. That'll be fine. So there we go. And we'll print it out. And here's the final result, guys. So this is our shade for the Blackmagic 3-inch remote HDMI monitor. And yeah, so here's the monitor here, and it seems to actually work pretty good. It goes over the monitor there. I did just guess the radiuses. They're probably a little bit sharper than the actual thing, but that doesn't matter. And yeah, look, it's going to protect the shade really, protect it from glare really, really well. So I'm really happy with this. It's my first ever proper Fusion 360 model, where I've properly put the time into dimensioning it, adding relations, and doing a lot of that sort of stuff. And actually, yeah, I'm actually quite happy with using Fusion 360 in terms of using it for a proper modeling package. So you can look forward to seeing a lot more Fusion 360 tutorials and projects here on Makers Muse, because yeah, it's free, it's powerful, and from what I can see, it does exactly what I need. I did notice also on the model that I printed on the Cetus, a few people were asking if the cantilever design induces any sort of errors or ringing, and I can confirm that, yeah, it actually seems to. So with this model, the side that was closest to the support is perfectly smooth, and the side that was further away has very obvious ringing. So that cantilever design definitely must induce a bit of vibrations as it gets further out. The print head moves further out, there's mass, and when it does the infill, that certainly must have a bit of an effect on the model. So to fix that, I guess, I mean, this was on a medium speed, like normal. You could go a bit slower, or I guess you could modify it to add a rod to support that. I don't know, but it's just worth noting, guys, that it does certainly seem to make a difference depending on how far away from the support you print. But overall, I am really happy with this model printed in their own brand of black PLA. So thanks for watching, guys. Hope you enjoyed this video here on Makers Muse. And if you want to watch more future 3D printing tips, tricks, reviews, and projects, smash that subscribe button. Helps me out a lot, and I'd love to have you on board. Also, we now have our t-shirts for sale over at Redbubble. So I made some shirts, and a lot of people requested that I could put them up for sale. So if you're interested in getting a Makers Muse shirt, then definitely check it out. And I look forward to seeing you again very shortly here on Makers Muse. Catch you later, guys. Bye.
Here's the latter half of the 20th century, and man has sent rockets into deep space. He has placed satellites into orbit. He has actually walked in space.